Good day, folks. My name is Ricardo Gutierrez, and I'm a Cloud Network Security Solutions Architect. And I would like to welcome you to the How to Connect to AWS in a Quick and Inexpensive Way, Part 3. Today, I will demonstrate the routing setup when using the side-to-side IPSec VPN tunnels using GRE tunnels to AWS. Before I go over the settings in Palo Alto, firewalls, and AWS, I want to go over the architecture so you have a good understanding of what we are trying to connect to from on-premises. So here you have your data center in the East Coast, for example, and you have active, passive Palo Alto firewalls. You have this computer or user that wants to connect to the web server that lives in AWS, and it's in the US East 1 region. You can see here we have 4 web servers, we have 2 load balancers, and we have the Transit Gateway. This is the same Transit Gateway. And we have the Palo Alto virtual firewalls running in AWS. As you notice in this demo, we have one internet connection on premises, and this firewall will connect to this virtual firewall in AWS via an IPSec tunnel. So this firewall from on-prem will build 2 IPSec tunnels, one to firewall 1 in availability zone A, and the other IPSec tunnel in availability zone B. This gives us redundancy and makes it more reliable. If one availability zone goes down, the other one's still up and your connection can still go through. Then from the virtual firewalls in AWS, we have built GRE tunnels. So we build one GRE tunnel per virtual firewall. In this case, we have this GRE tunnel built into this Transit Gateway, and this GRE tunnel is going to from this to this Transit Gateway from this firewall. It's very important to mention that the Transit Gateway needs a CIDR assigned, and the smallest one you can provide is a /24. Our BGP peers will be these IP addresses. So GRE1 will have these 2 IP addresses, and GRE Tunnel 2 will have these IP addresses. So from a redundancy perspective, the firewall will have connectivity, 2 BGP sessions from the firewall to the Transit Gateway, and this other firewall we have 2 BGP sessions to the Transit Gateway. Now I'm going to give you a quick packet flow walkthrough, and let's say this computer here is 10.022.12. It's a user wanting to reach the web servers here. In this case, this web server will hit the ALB IP address. So when the user wants to hit the ALB's IP addresses or FQDN, the packet will be received to the active firewall on the network, and then this firewall has ECMP built into it or set up, and it will round robin to each of these firewalls. So let's say session 1 to connect to, from this computer to connect to the web server or the load balancer will go through this IPSec tunnel. And then let's say I refresh the connection, and then session 2 will go over this other IPSec tunnel into this other firewall. So in this case, you're leveraging your IPSec tunnels. So it's not a failover connection, it's an active, and you make the most out of your virtual firewalls, and you also improve performance and throughput because Now you have two firewalls that can handle up to 5.6 gigabits of throughput. Then once the packet hits the firewall, any of these, the firewall will forward the packet to the what is called a RAS Connect attachment, which is the attachment that has BGP built into it, and the Transit Gateway and the Palo Alto are exchanging routes via BGP. Then once it hits the RAS VPC attachment, it'll send the packet to the spoke VPC attachment, and then it will send the packet to the load balancer right here. In this case, this is an ALB, and the ALB has target groups of these web servers. And as you can see, there are 6 hops to get from on-premises to the web server, or to the load balancer, I should say. Okay, now we're going to go over the ECMP routing setup, and I will go over the IPSec of connectivity and some of the BGP settings on the firewall and in AWS. Okay, now let's go over the routing settings and the IPSec tunnels. The firewall on your left is the on-premises firewall, and the firewall on the right is one of the virtual firewalls in AWS. So here we are on the VR, it's called default VR, and you will see that ECMP has been enabled. The max paths are set to 4, and we're using the load balancing method of balance round robin. On the other firewall, we have the same setup. So this will allow for all the BGP peer connections to round robin traffic between them. So in this case, it will be between firewall 1 and firewall 2. Now we'll go over the IPSec tunnel connections, and here you will see that they are online. This is the on-prem firewall, and then the firewall in AWS. They are up, and as you can see, this IP, this is the same IP as the peer right here. So they are connected. Now that the IPSec tunnels are online, the BGP peers will be online as well if everything's set up correctly. So we'll go to the default VR that we have here. We'll click on more runtime stats. We'll click on the BGP tab. We'll go to peer, and then you will see that we have the BGP session established. Now we'll do the same on the AWS firewall, BGP, peer, and you can see this is my DC1. This is this data center. These here are the GRE tunnels BGP sessions. Once we have the BGP sessions online, then we'll be able to see routes on our firewalls. In this case, on the on-prem firewall, I will go to routing. I will type 10.250. This is, if you remember, the IP address of the load balancer and the spoke VPC. So as you can see, I have 2 ways to get to that load balancer. And here we'll go on the AWS firewall, and you can see I have one way to get there from that firewall, and this is because this is firewall in AZA, and it only has one IPSec tunnel, so you only have one connection and one route back to this on-prem network. So once the BGP session is online, now we can check the BGP local RIP and check out the routes. So as you can see, to get to 10.0250, I can see the routes through these two peer connections, these two BGP peers. And on the AWS side firewall in AZA, I only have one peer because firewall in AZA only has one IPSec tunnel to on-prem. Now on the AWS firewall, we will see the prefixes learned from the Transit Gateway. So I will type 10.250 and voila, this is coming from the BGP peer connection to the Transit Gateway, and that connectivity, remember, is built using a GRE tunnel on the AWS firewall. So I will show you where that is set up. We have this GRE tunnel and we have all the settings. This is the peer address, this is the IP address that the Transit Gateway has in order to build that BGP session. So thus far we've seen how the on-prem firewall and the cloud firewall exchange routes, right? So now I'm going to show you how the Transit Gateway advertises or propagates those routes into the AWS firewall. So how do we advertise those VPC prefixes into BGP and into the Transit Gateway? Well, as you can see here, I have the RAS VPC Connect Transit Gateway route table, which has propagated the spoke VPCs. In this case, this is spoke one, where the web servers are at, and spoke 2, where other web servers are at. And as you can see, they were propagated into this route table. If we go here, you'll see that I attach the VPCs, spoke 1, spoke 2, and the RAS VPC here to connect to the management interface of the firewalls from on-prem. So for the return traffic, we need to also build a spoke VPC Transit Gateway route table. And the only reason I'm doing this is because I want to keep different route tables so the VPCs cannot talk to each other. This will isolate them. So in this spoke VPC Transit Gateway route table, I associated the spoke 1 VPC and spoke 2 VPC. And then I propagated the RAS VPC connect attachment. The connect attachment is the one that builds the BGP connectivity. And if we go to the route tables, you will see the routes that have been learned from on-premises. As you can see, I have these networks, 10.0010, that's where my panorama lives. This is one of my networks, an on-prem network, and these are global protect networks. And as I was saying about the RAS VPC Connect attachment, this is a must. So once you build that, you will need to build connect peers. And in the connect peers, that's the GRE tunnel build. So in this case, I have firewall 1 GRE tunnel, right? And this is the IP address on the Transit Gateway. This is the firewall's trusted interface IP address. This is the CIDR that will be used to build the BGP peers. This is the Transit Gateway's ASN, and this is my cloud firewall ASN. You can also see here the BGP address. This peer address is the IP address that you will use on your tunnel interface on the firewall. Then these are the IP addresses used on the Transit Gateway. These are built by AWS automatically, so you don't have to hard code anything. As I said, these IP addresses are used to build the BGP peer connection. Now we'll give you a quick demo of how the computer from on-prem will connect to the load balancer in Spoke 1. And I will just refresh the screen. Right now I have an active connection. We'll look at the timestamp, it's 2:11, and I will refresh the screen. So right now, as you can see, I connected to the web server with IP 10.250.1.24 from this source IP, and I'm using HTTP. This is not encrypted, it's just a test, a sandbox environment. So I will hit again, refresh. You see, now I'm going to web server 2 from the same source IP, and I will do it once more, and now it's using the other web server, and again I'll hit refresh, and it's using the other web server in AZB. So right now I will demonstrate how traffic is load balancing between the two firewalls in AWS from on-prem. And as you can see on the screen, this is the FQDN of the internal load balancer having AWS and Spoke 1 VPC. And these are the IPs that it resolves to. This is in AZ8, availability zone A, and availability zone B. Now, if we go to the firewall, this is the on-prem firewall, you will see that my connection is sourcing from this IP, right? And the destination, if you remember, you saw 112, ended in 112, and 193. Now, to identify that it's load balancing between the two firewalls, you can see that connection to to load balance with IP with 112, it goes through tunnel interface 31. And if you notice on this session is going to tunnel interface 32. So the firewall is load balancing between the two firewalls and AWS. And as you can see here, there's another session going to the 193 IP address, and that's using tunnel interface 31. So in that case, that session went through firewall in AZA. And here, these are the firewalls in AWS. In this case, this is firewall in AZA. And you can see the traffic coming from 10.0.22.12. Look at the timestamp 11.13. And firewall in AZB has a similar timestamp. But you can see the traffic is load balancing between them. So this is what we covered in this video. We went over the architecture overview, ECMP. We went over the IPSec tunnels. I showed you when they were online, and the GRE tunnel setup. We also saw the BGP peers online from on-prem, on the REST firewall, and in AWS. We also looked at the BGP routes in the local RIB and how the firewalls were learning those routes. This type of connection, the site-to-site IPSec VPN using GRE tunnels, is one option. You can use it as your primary connection if you don't want to spend the money on a dedicated circuit and having equipment at Equinix. This is the way to go. Or this could be a backup connectivity to that primary connection using Direct Connect and a circuit at Equinix, for instance. This concludes the video. I hope you found it useful, and thank you for watching. Well, thank you very much for watching, and look in the description below so you can get a chance to see the discounts and other free content. And please join the club. And if you need custom training, look in the description below. There will be a URL that will send you to a form that you can fill out and request your training. Some of it might be free, some of it might be paid, but feel free to fill out the form. And please like and share and subscribe and join the club. Thank you and have a good day.